So, this is our fourth lecture in which we are going to cover up chemical bonding. सबसे पहले मैं मॉलिक्यूलर ऑर्बिटल थ्योरी के एक दो बेसिक कंसेप्ट आपको बताना चाहता हूँ, लेकिन आपने रिक्वेस्ट किया था स्टार्टिंग में, तो वही बता देता हूँ। सो मॉलिक्यूलर ऑर्बिटल थ्योरी में देखो, सबसे पहली चीज जो आपको समझनी है वो दो है। बेसिकली यहाँ पे हम लोग वेव फंक्शन ऑफ एटॉमिक ऑर्बिटल्स को टैकल करते हैं, और यहाँ पे जो कंसेप्ट अप्लाई होता है वो होता है लीनियर कॉम्बिनेशन ऑफ एटॉमिक ऑर्बिटल्स। यानी कि वेव फंक्शंस को या तो हम ऐड करते हैं या सब्ट्रैक्ट करते हैं, या इसी को अगर फिजिक्स के एंगल से बताऊं तो कंस्ट्रक्टिव और डिस्ट्रक्टिव इंटरफेरेंस ऑफ वेव्स का कंसेप्ट है। सो अगर हमारे पास कोई दो वेव फंक्शन है, मैं उनको ऐड करता हूं या सब्ट्रैक्ट करता हूं, तो इट इज लीनियर कॉम्बिनेशन ऑफ एटॉमिक ऑर्बिटल्स व्हिच लीड्स टू द फॉर्मेशन ऑफ मॉलिक्यूलर ऑर्बिटल। और सेकेंडली वी कैन से कि अगर हमारे पास दो वेव फंक्शंस हैं, वो अगर सेम फेज में ऐड हो रहे हैं तो कंस्ट्रक्टिव डायरेक्शन में जा रहा है, बॉन्डिंग मॉलिक्यूलर ऑर्बिटल बनाएगा। अदरवाइज अपोजिट डायरेक्शन में आए तो डिस्ट्रक्टिव इंटरफेरेंस फॉलो करेगा, एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल बनाएंगे। सेकेंड इंपॉर्टेंट थिंग इज, एटॉमिक ऑर्बिटल्स में फिलिंग के जितने भी रूल्स अप्लाई होते हैं वो सारे के सारे रूल्स मॉलिक्यूलर ऑर्बिटल पे भी अप्लाई होते हैं। ठीक है। यहाँ पे एक इंपॉर्टेंट पॉइंट है जो आपको याद रखना है। अप टू 14 इलेक्ट्रॉन सिस्टम जब हम लोग डील करते हैं, तो अप टू 14 इलेक्ट्रॉन सिस्टम में जब हम 8 टू 14 इलेक्ट्रॉन डिस्कस करते हैं, यानी 8 इलेक्ट्रॉन के बाद का केस अगर लेके चले, लेट से 9 इलेक्ट्रॉन टू 14 इलेक्ट्रॉन का सिस्टम लेते हैं, तो इसमें जो हमारा एटॉमिक ऑर्बिटल है एस और पी, इसमें क्या होता है कि अगर हमारे पास 9 इलेक्ट्रॉन का सिस्टम है, 9 इलेक्ट्रॉन सिस्टम या बेटर टू से 10 इलेक्ट्रॉन सिस्टम, तो हम जैसे B2 के केस में पहुंच रहे हैं, तो एटॉमिक ऑर्बिटल के केस में 5 इलेक्ट्रॉन का केस हुआ। तो हमने अगर 1s2 वाले दो इलेक्ट्रॉन हटा दिए, तो मैं 2s और 2p से लेट से डील कर रहा हूँ, तो 2s के दो इलेक्ट्रॉन और 2p में एक इलेक्ट्रॉन, तो अभी हमारे पास 5 इलेक्ट्रॉन हो गए। तो एक में 4 एक में 5 हुए तो 9 बनेगा, या 5 5 लिए तो 10 इलेक्ट्रॉन बनेगा। सो फ्रॉम हियर यू कैन सी कि p ऑर्बिटल में एक इलेक्ट्रॉन जा रहा है, जो अप टू 14 इलेक्ट्रॉन सिस्टम तक जब हम पहुंचेंगे तो 2p3 कॉन्फ़िगरेशन तक पहुंच जाएगा। एंड एज यू ऑल नो दैट हाफ फील्ड कॉन्फ़िगरेशन की स्टेबिलिटी बढ़ती है बिकॉज ऑफ एक्सचेंज एनर्जी। तो जब हम 2s और 2p की एनर्जी स्टडी करते हैं, एंड इन दिस केस 2p की एनर्जी जो है वो धीरे धीरे डिक्रीज करती चली जा रही है। सो एनर्जी ऑफ 2s एंड 2p बिकम्स वेरी क्लोज। और यहाँ पे एक कंसेप्ट इनकॉर्पोरेट हो जाता है जिसको हम लोग एस एन पी इंटरमिक्सिंग बोलते हैं। यहाँ पे एक कंसेप्ट इनकॉर्पोरेट होता है जिसको हम लोग एस एन पी इंटरमिक्सिंग बोलते हैं। एंड बिकॉज ऑफ दिस इंटरमिक्सिंग, एस एन पी इंटरमिक्सिंग इन्वॉल्व हो जाती है। एंड बिकॉज ऑफ दिस एस एन पी इंटरमिक्सिंग व्हाट हैपेंस, पाई टू पी एक्स एंड पाई टू पी वाई के जो एटॉमिक मॉलिक्यूलर ऑर्बिटल्स हैं, इसकी एनर्जी हमारी सिग्मा टू पी जेड से कम हो जाती है। रूल के हिसाब से सिग्मा टू पी जेड की एनर्जी कम होनी चाहिए थी, पाई टू पी एक्स पाई टू पी वाई एनर्जी ज्यादा होनी चाहिए थी, क्योंकि पहले मोस्टली सिग्मा बॉन्ड फॉर्म होता है, देन इट गोज टू अ पाई बॉन्ड। बट एस एंड पी इंटरमिक्सिंग होने की वजह से पाई टू पी एक्स पाई टू पी वाई बनने की वजह से की एनर्जी टू पी सिग्मा टू पी जेड से कम हो जाती है। अब अगर हम इस चीज को बी टू मॉलिक्यूल पे अप्लाई करते हैं, तो इन केस ऑफ बी टू द फिलिंग ऑफ इलेक्ट्रॉन इज सिग्मा वन एस टू, सिग्मा एंटी बॉन्डिंग वन एस टू, सिग्मा टू एस टू, सिग्मा एंटी बॉन्डिंग टू एस टू, एंड पाई टू पी एक्स वन एंड पाई टू पी वाई वन। अब ध्यान से देखिए, अगर इलेक्ट्रॉन की फिलिंग पहले टू पी जेड में जाती है तो दोनों इलेक्ट्रॉन पेयर हो जाते हैं। बट यहाँ पे दो अनपेयर्ड इलेक्ट्रॉन जनरेट हो रहे हैं जो इस मॉलिक्यूल को पैरामैग्नेटिक बना रहे हैं। सो वी हैव टू अनपेयर्ड इलेक्ट्रॉन्स। अब देखो यहाँ पे एडवांस में दो तरह के क्वेश्चंस आते हैं, दोनों समझा रहा हूँ। सो टू अनपेयर्ड इलेक्ट्रॉन्स मीन्स इट इज पैरामैग्नेटिक। अगर एस एन पी इंटरमिक्सिंग इन्वॉल्व नहीं होती, कभी कभी ऐसे क्वेश्चन लिख के आएगा दैट एस एन पी इंटरमिक्सिंग इज नॉट इन्वॉल्व, देन दैट केस यू हैव टू राइट द रूटीन ऑर्डर, जहां पे आपको सिग्मा टू पी जेड की एनर्जी कम करनी पड़ेगी, विच यू कैन ट्राई फॉर ओ टू। इफ इट इज ओ टू देन एस एन पी इंटरमिक्सिंग इज नॉट ऑपरेबल, तो सिग्मा वन एस टू, सिग्मा एंटी बॉन्डिंग वन एस टू, एंड देन सिग्मा टू एस टू, सिग्मा एंटी बॉन्डिंग टू एस टू, then we write sigma 2p z2, pi 2p x2, pi 2p y2, and then pi anti-bonding 2p x1 and pi anti-bonding 2p y1। अब ध्यान से देखो, इसमें भी दो अनपेड इलेक्ट्रॉन और पैरामैग्नेटिक स्टेट है। सो B2 और O2 में बेसिक डिफरेंस क्या हुआ, अरेंजमेंट सेम है, बट द difference is that S and P intermixing is operated in B2 which is not operated in O2। एडवांस के लेवल पे दोनों तरह से क्वेश्चन आ सकता है। दे मे राइट दैट सपोज यू विल कंसीडर a specific condition in which S and P intermixing is not involved, then bond order or like any property of B2 is asked, so that you have to deal in such a manner where S and P intermixing is not operated, then different answer will be there. And if it is operated, then it will be a different answer. Another important thing is like if I deal with the bond order of B2, then you can see that number of electron in bonding molecular orbital are total 6 and number of electron in anti-bonding are 4. So by 2 bond order comes out to be 1. But here this bond order 1 actually reflects this pi bond. So this one bond is pi bond. Okay. So mostly like if you will deal with valence bond theory, you will feel like that first bond formed is a sigma bond, but here the first bond formed is pi bond. Or sometimes it is asked that in which of the following case number of pi bond form, sigma bond form. So that and all we have to deal. Then if MOT is involved, you have to deal it like which type of molecular orbitals are involved in the bonding. Second important concept what you have asked about, that was HOMO and LUMO concept. So that is also not much in our syllabus. So fundamental will be more than enough. So if I write HOMO and LUMO concept, so HOMO is called highest occupied molecular orbital. So highest occupied molecular orbital means it is the molecular orbital in which electron is present and it is of highest energy. And when you say LUMO, it is called lowest unoccupied molecular orbital. So lowest unoccupied molecular orbital means it is the molecular orbital which is unoccupied, means it is vacant and it is lowest in that energy because all other vacant molecular orbitals have higher energy than this. Okay. So these HOMO and LUMO are very important because mostly electron transitions takes place in between these two molecular orbitals and mostly it is responsible for colors in the compounds. Like if I deal the colors of halogens, let's say F2, Br2, Cl2, I2, if I deal with colors of let's say F2, Cl2, Br2, I2, etc. So here it is the concept of HOMO and LUMO. In that case, the last electron present in highest occupied molecular orbital can shift to lowest unoccupied molecular orbital. And when this electron returns to the ground state, it can like release a photon of visible region, which cause the color in these count of compounds. So such kind of explanations can be used. And if you have to find out highest occupied and lowest unoccupied molecular orbital, so let us say I'll take the example of B2 itself. So in case of B2, if I write highest occupied molecular orbital, so the electron present in highest molecular orbital is pi 2p x1 and pi 2p y1. So they are HOMO for this. So pi 2p x1 or better to say pi 2p x and pi 2p y, both are of same energy. So here two molecular orbitals are HOMO, which is highest occupied molecular orbital. And if I write its lowest unoccupied molecular orbital, then it will be sigma 2p z. Because if I have to fill up the next electron, then the vacant orbital is sigma 2p z. Clear? And if I do the same thing for O2, then in case of O2, the highest occupied molecular orbital is pi anti-bonding 2px and pi anti-bonding 2py, which have same energy, in which we have to fill up the occupies which contains the electron. और यही काम अगर LUMO चेक करेंगे ऑक्सीजन से, लोएस्ट अनऑक्यूपाइड मॉलिक्यूलर ऑर्बिटल इज सिग्मा एंटी बॉन्डिंग 2pz. So highest occupied molecular orbital means in which electron is present. Lowest unoccupied molecular orbital means which is vacant but it is of lowest energy. So likewise we can deal different molecules. Another point you have asked about the what are the nodal planes and all. So for that you should know that if we do the overlapping in the same phase, it will undergo constructive interference form bonding molecular orbital, else it will go undergo anti-bonding molecular orbital. So like it is a routine diagram I have taken. So 1s orbital is it has been taken. So this is the plane where electron density is 0. So for this case you can say this is nodal plane. When you do the same thing for p orbitals, then in case of p orbitals, there are two possibilities. Either they can form sigma bond with constructive interference, or you can say same phase overlapping. So here you can notice that these two p orbitals are overlapped with the same constructive overlapping thing. Why constructive? Because both have plus plus phase. Don't confuse, the plus phase contains plus phase means they are in the similar phase, and once they are in the same phase, that means they'll form constructive inference, or they can form the what you'll say molecular bonding molecular orbital. So electron density will be increased in the in between orbital, So here, if I'll discuss about the like nodal plane, then you can write these are the planes. Okay. And if we discuss about the anti-bonding molecular plane, so this is the plane which is marked as nodal plane. And in case of p orbital, there is one more kind of overlapping possible, which is lateral overlapping, which can lead to the pi bond formation. So if we take two px orbital in the same phase, these are in the same phase plus plus. So same phase overlapping means it will form bonding molecular orbital, and if they are in the opposite phase, they'll form anti-bonding molecular orbital. So here we are subtracting these two orbital means anti-bonding molecular orbital will form. Here we are adding the two orbitals, so it is bonding molecular. If in case of subtraction, we can also write it as in the opposite phase overlapping means the same plus minus phase if you replace and you will simply write add, so that can also lead to the anti-bonding molecular orbital. So in that case also you can see the nodal planes. So anti-bonding pi molecular orbital has a nodal plane which is shown. This you can refer to as nodal plane. So likewise we can discuss about different nodal planes in different molecular orbitals, which is a routine practice. आपको सिर्फ डायग्राम अगर ठीक से क्लियर होगा या टाइप ऑफ ओवरलैपिंग क्लियर होगी तो आप आसानी से बॉन्डिंग या एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल पे पहुंच जाओगे। एक क्वेश्चन बहुत इंपॉर्टेंट है, मैं उसी से सारा कंसेप्ट आपको एक्सप्लेन कर देता हूँ। या दिस इज क्वेश्चन, दिस क्वेश्चन वाज वेरी ब्यूटीफुली फ्रेम्ड, बट थोड़ा सा फ्रेमिंग ऑफ क्वेश्चन जो लाइक एक्सप्लेनेशन पार्ट था उसमें एक्चुअली मैं आईआईटी ने मेंशन करना भूल गए, लाइक आप मॉलिक्यूलर ऑर्बिटल थ्योरी के रिस्पेक्ट में डिस्कस करो। सो इट बिकम्स अ वेरी इजियर क्वेश्चन बिकॉज once it is asked undergoes oxidation and undergoes reduction means it is loss of electron and gain of electron, which is practically possible with any of these molecules, because until unless bond order becomes zero, so if bond order becomes zero, then only you can say that molecule is not possible. So in any of the molecule, if I'll ask like whether oxidation is possible or reduction is possible, then what you have to check after addition of electron or after removal of electron. Oxidation is loss of electron. So after removal of electron, if a species form in which bond order is zero, that means it cannot be formed. And once it cannot be formed, means oxidation is not possible. If I'll form, like if I'll undergo reduction, it is gain of electron. So if a molecule gains an electron, and after that a species form in which bond order is zero, then also reduction is not possible. In rest other cases, oxidation reduction is favorable. The only difference is more favorable or not favorable. If bond order is increasing, that means it is more favorable. If bond order is decreasing, it is lesser favorable. So in this question, it has to be mentioned clearly. Then it would have been a good question that कि हमें like bond order increase का decrease का case consider करना है या नहीं करना है. But in this case, it is only asked oxidation reduction. So हम simple routine से चलेंगे कि अगर किसी भी substance का oxidation highest या lowest नहीं है तो उसमें दोनों प्रॉपर्टीज होती हैं, ऑक्सीडेशन भी हो सकता है, रिडक्शन भी हो सकता है, बिकॉज ऑक्सीडाइज एंड रेसिक एजेंट इज नॉट डिफाइंड इन अ पर्टिकुलर केस. So in this question, like option Q and R becomes dummy for all the options. So if I have to deal with option A, B, C, D, so I'm just like explaining the question through answer because like I don't want to spend more time on this question because most of you have attempted this question earlier, would have definitely attempted this question earlier. So एक बार जल्दी से देख लो बस. So in this case, basically, as I have told you already, S&P intermixing is involved in the case of 8 to 14 electron system. So B2 and N2 undergoes S&P intermixing. So for option A, Q and R is common for all, which I hope every one of you can notice that Q and R are the common options, जो आप सबको ही पता है, like this. So this is one option. Q and R आप सब में देख लो common option है, क्योंकि मैंने पहले क्लियर कर दिया कि वो डमी ऑप्शन था क्वेश्चन के लिए. नेक्स्ट पार्ट जो हमें देखना है वो मैंने बताया B2 एंड N2 के लिए पहले क्लियर किया है, S&P इंटरमिक्सिंग है विच इज नॉट पॉसिबल इन O2 माइनस एंड O2. सो टी ऑप्शन देखिए इन दोनों केस में ऐड कर दिया. आफ्टर दैट यू हैव टू सिंपली चेक बॉन्ड ऑर्डर एंड other paramagnetism and diamagnetism case. So you know B2, O2 minus and O2 are paramagnetic. So paramagnetic thing is added in A, C and D. Nitrogen is diamagnetic. And bond order is greater than or equal to 2. So for bond order, B2 is 1, N2 is 3, O2 minus 1.5, and O2 is certainly 2. So like you have to just leave case of B2 where bond order is 1. So S will not be present with option A and C. इट इज अवेलेबल विद बी एंड टी। सो इट्स अ वेरी रूटीन क्वेश्चन जो आप बहुत आसानी से समझ जाओगे। बस कंसेप्ट जो मैंने अभी बताया उसको सीधे सीधे इंप्लीमेंट कर देना है। एक बात बस याद रखनी है जो मैंने बताई कि बॉन्ड ऑर्डर जीरो का केस इंपॉर्टेंट होता है जब भी आप ऑक्सीडेशन रिडक्शन का केस डील करेंगे। सो बी केयरफुल, अगर बॉन्ड ऑर्डर जीरो आ जाएगा देन यू कैन से विद सर्टेनिटी दैट ऑक्सीडेशन रिडक्शन इज नॉट पॉसिबल। रेस्ट ऑल केसेस में ऑक्सीडेशन रिडक्शन कंसीडर कर लेते हैं। चांसेस आर दैट मोर फेवरेबल और नॉट फेवरेबल, दैट पार्ट वी कैन डिस्कस। वो मैंने आपको पहले ही बताया कि बॉन्ड ऑर्डर इंक्रीज होने का केस नॉर्मली फेवर करता है और बॉन्ड ऑर्डर डिक्रीज करने का केस नॉर्मली फेवर नहीं करता है। क्लियर? डन। नाउ वी मूव टू सर्टेन क्वेश्चन जिसमें थ्रू मैं सारे कंसेप्ट कवर करते हुए चल रहा हूँ। आई ट्राई कि मैक्सिमम चीज़ें आपकी अच्छे से कवर हो जाए। सो लेट्स सी विद द फर्स्ट क्वेश्चन। Okay, one more thing you have asked, just give me a minute. That was like when we have to discuss about which we have to discuss about hybridization in case of different physical state. So as you all know that hybridization in case of solids and liquid case we have to discuss. Just give me a minute. Thanks. Just a minute. So hybridization in solid and liquid state or in case of self-ionization, all those cases are like very common. So some of you have requested for that. So I'll tell you like PCl5 in solid state exists as PCl4, PCl6 minus. You can simply draw the structure and get the hybridization. PBr5 solid exists as PBr4 plus Br minus. That also like Br minus becomes unhybridized state and it exists in a hybridization of PBr4 plus sp3. N2O4 solid exists as NO plus NO3 minus. NO plus can be taken as sp hybridization. sp2 is in NO3 minus. N2O3 exists as NO plus NO2 minus. N2O5 solid exists as NO2 plus NO3 minus. Iodine exists as I3 plus I3 minus. I2Cl6 can be taken as ICl2 plus ICl4 minus. So in this kind of things, like they can ask like find the hybridization in anionic state, cationic state, bond angle things can be asked. So unless you are not aware about the structure, you are not comfortable while answering such questions. So I2Cl6 exists as ICl2 plus and ICl4 minus. इसका Cl2O7 डील करेंगे तो ClO3 प्लस ClO4 माइनस। XeF6 सॉलिड फॉर्म में एग्जिस्ट करता है XeI5 प्लस एंड F माइनस। ये तो डायरेक्ट हो गया स्टेट्स ऑफ मैटर के साथ हम डिफरेंट डिफरेंट फिजिकल फॉर्म में कन्वर्ट करते हैं। इसके बाद एक और पार्ट क्वेश्चन का इन्वॉल्व है जिसमें हम लोग आयनिक थ्योरम को भी लिंक कर सकते हैं जो बाद में डील कर लेंगे अभी। सो दिस इज बेसिकली सेल्फ आयनाइजेशन कॉन्सेप्ट। सो जो कॉमनली हम लोग वाटर के लिए यूज करते हैं आयनिक थ्योरम में, बट देयर आर सम मोर इनऑर्गेनिक सब्सटेंसेस जहां पे आप सेल्फ आयनाइजेशन या सेल्फ डिसोसिएशन को इन्वॉल्व कर सकते हैं। सो आई हैव टेकन एन एग्जांपल ऑफ ICN। So ICN undergoes self-ionization. It can form I2CN plus and ICN2 minus. अब जिनको देखो ब्लॉक केमिस्ट्री का थोड़ा आइडिया है उनके लिए तो ठीक है, अदरवाइज आप समझ सकते हैं जो I माइनस है इसको हम लोग हेलाइड बोलते हैं और जो CN माइनस होता है इसको सूडो हेलाइड बोलते हैं। तो कई बार इसका प्रयोग करेंगे हम लोग जहां पे भी आपको हेलोजन रिप्लेस करना हो वहाँ CN माइनस यूज करेंगे। दिस इज रिफर्ड एज सूडो हेलाइड। सो सूडो हेलाइड मतलब ऐसे नाइट्रोजन कंटेनिंग कंपाउंड जिनका रिएक्शन हेलोजेंस की तरह होता है। तो एडवांस के पेपर में ये चीज बहुत कॉमन ट्रिक की तरह यूज की जाती है। आप हेलाइड याद करके जाओगे और सूडो हेलाइड का क्वेश्चन डील करेंगे तो कंफ्यूज नहीं होना है। जो चीज आप हेलाइड के साथ डील कर रहे हो द सेम थिंग यू कैन डू विद सूडो हेलाइड्स। सो आई एम टेकिंग ICN, so it is taken as I2CN plus ICN2 minus. Structure if I draw, then here I2CN it is given. So one iodine is bonded, another CN is bonded. In iodine central atom, total 6 electrons were left out. So its hybridization will be sp3 here. And if I deal with carbon and nitrogen, so they both will be sp hybridized. That you can easily answer. And in case of ICN minus, both CN will be just like halogen, so it is like I3 minus. So here hybridization will be sp3d and it will become a linear geometry. And again, similar type of question can be formed like they can ask in an ionic species the d orbital involved in the hybridization or shape of that molecule, number of lone pair, number of pi bond. So different things can be asked. Here carbon and nitrogen are again sp hybridized. So that you can easily answer. So hybridization thing will can be asked, like different kind of geometrical aspects can be asked. Dipole moment can even be considered because I3 minus is a linear molecule, so net dipole moment will be cancelled out. Similarly, if I deal with self-ionization of BrF3, so BrF3 will undergo self-ionization will form BrF2 plus and BrF4 minus. So if you deal BrF2 plus, then it is again sp3 hybridized and it is definitely bent shape. And if I deal with BrF4 minus, so it will be sp3d2 hybridization and it will be square planar. So even this kind of question can be asked that how many 90-degree angles are there in anionic state. So here you know that it is since it is a perfect square planar geometry, lone pair repulsions are cancelled out. So this molecule is perfect square planar. All the bond angles will be 90-degree. So self-ionization means gives you more stable forms or self-ionization product should be known and then you can simply draw the structure and discuss the hybridization. Self-ionization of water is a routine process which we mostly complete in ionic equilibrium thing. You all know that Kw for this process is 10 power minus 14. So similar type of questions can be correlated for other compounds also, where we can write like self-ionization constant and then we can create different type of question related to physical chemistry. As of now, we are discussing inorganic chemistry, so just focus on the structure part. So water is sp3 hybridized, then H3O plus is also sp3 hybridized, and OH minus is also sp3 hybridized only because it has 3 lone pair, 1 sigma bond. Case has varied, result remains the same. Similarly, we can deal self-ionization constant or self-ionization of ammonia also. In case of ammonia also, you can notice it very carefully that in case of ammonia also, if you draw the structure, there is no change in hybridization and self-ionization. Whereas in the first two cases, when we have discussed about the hybridization, they all have different hybridization. But in this case, if I discuss the hybridization, it is same. Like in BrF3, if you deal, that is sp3d hybridization T shape. Then it has converted to sp3 and sp3d2. Whereas in case of ammonia, after self-ionization constant, it was sp3 hybridization. This one is also sp3 hybridization and this is also sp3 hybridization. The difference is only of that in this case we have 3 sigma bond and 1 lone pair. Second case we have all 4 sigma bond and third case we have 2 sigma bond and 2 lone pair. So with respect to angle, definitely things will change. We can definitely discuss about NH and bond angles in all three cases. Like we can ask like how the bond angle will be changed in the from reactant to product. That can be a question because ammonia when convert to a cation, bond angle will certainly increase because lone pair bond pair repulsion decreases the bond angle. So like if I ask a question in terms of bond angle, I can say theta 1 over here, theta 2 over here, and theta 3 over here. So I can easily write that theta 2 will have the highest value, then it is theta 1, and finally it is theta 2. So like that, we can compare the bond angles and similar different other questions can be created. So you must know about the hybridization in different physical states, and then this self-ionization concept can also be introduced. And if we can create a paragraph type of question in which first question can be more related to inorganic chemistry, and then with self-ionization constant, I can definitely switch the same question to a ionic equilibrium question. So that type of amendments or that type of questions will deal when we'll do some more chapters so that like you will have little more command over inorganic and physical together. Then only we can handle such type of question or like even during the final revision sheet or final revision time, we can do such kind of like experiments with the questions. Now I'm like coming to the point which from which I have started discussion of inorganic chemistry, where I said that inorganic chemistry is a fact-based chemistry where explanation part should be very important. And this assertion reason type of question is like the key, or you can say one of the toughest question for inorganic chemistry because if you know the fact, then explanation should also be known. Let us say I'll deal with this question. And I have taken a different type of options also. If you have done assertion region earlier, so just go through the options differently. Here I have taken A option as when it is S is correct and E is wrong. Here S I am saying as a statement, E I am saying as an explanation. That's why I have used the term S and E. If you want to do it as an assertion region, you can write A and R also, or any other like convention can be used. For me, the question is statement and explanation. Or you can say like it is a different kind of experiment with the question. So S is for statement, E is for explanation. So in statement S, it is given PCl3 on hydrolysis gives OH, P double bond OH and H. Since you know during the hydrolysis of water as a low nucleophile will attack on the phosphorus element, and then Cl minus will be leaved. So if you observe the molecule for the first part, then all of you can notice that all three Cl will be replaced and three OH will be formed. So second structure will be in your notice. But since you know that S3PO2, S3PO3 is not the structure as I have written the second one, so it will be definitely converted into a first one through hydrogen bonding. Okay. And if that is the possibility, then see in the explanation it's given S3PO3 exists in two tautomeric form. Why I'm saying tautomeric form? Because those two structures are not resonating structures. You can notice that relative position of H is different. So they are basically two tautomeric form. So this is actually the correct statement and correct explanation for the question. So for this question, our answer will be C. I hope tautomeric thing is clear to you. So here answer will be C for me, which is this one. Got it? Why I said tautomeric? And here you can notice like terminologies of organic chemistry once incorporated in the inorganic chemistry, it becomes very tough to decide because we are not mentally prepared for this tautomerism thing. Like in H2O2, we are also using tautomerism. In HNO2, we are using tautomerism. So here, what exactly we are doing? We are shifting one H from oxygen to phosphorus. We are shifting one H from hydrogen to phosphorus. And in that case, we are getting the structure which is more stable than the previous one structure. And that's why after hydrolysis, we get S3PO3. What's the key concept? Because in most of the hydrolysis reactions, since water is neither an oxidizing agent or not a reducing agent, so whenever hydrolysis takes place, oxidation changes mostly not observed. In PCl3, phosphorus oxidation state is +3, so acid must be formed of +3 oxidation state. There are a few cases where such kind of changes are possible that mostly takes place in case of mixed anhydrides. Let's say HNO2 hydrolysis if you'll perform, or HNO2 if you'll add water, sorry, like in NO2 if you'll add water, then definitely NO2 is a mixed anhydride. It will form a mixture of HNO2 and HNO3. So oxygen state of nitrogen will change from +4 to +3 and +5, which you can also tackle as then average of +3 and +5 is +4. So point is basically movement, treatment of water mostly does not change its oxidation states. So like explanation part, like a statement part is very clear. Explanation part will come after reading it. You can think of that if they are two different automeric forms, then form one will definitely convert into form two, which is the actual hydrolysis product. But if you know the rule of hydrolysis, so it is attack of water as a nucleophile, substitute the Cl minus. So like product will form like second one as we do with respect to organic chemistry kind of thing. If I'll do hydrolysis, first I'll get this type of product. And once this product has formed, then definitely what will happen? Answer will be not this one. So definitely you have to think about the second structure, which you can easily understand by tautomerism kind of concept. Clear? So such type of questions are very important in inorganic chemistry where explanation is very important about the question, which you must understand by going through the question. Now let me take another question where I have taken that how many of the following have no hybridization, which is mostly related to Drago's rule. I hope all of you are aware of the fact that the hybridization is basically linked with bond angle. Mostly we use the term hybridization index, SPI term is used where I is called hybridization index. And this I is basically equal to -1 upon cos theta, where cos theta is bond angle. So as you all know that hybridization is a mathematical concept and it should support the bond angle data. So let us say I'll discuss about simply first SP hybridization. So SP hybridization means I is 1 for me. So cos theta is equal to -1 and definitely you can say theta is 180 degree. One more example if I'll write for you, if I'll take SP2 hybridization, so I is basically 2 and then cos theta is -1 upon 2, which you can say theta is 120 degree. or similar examples we may also find. So basically, hybridization is linked with bond angle. If bond angle data is closest to the bond angle, what is expected from the hybridization or from the hybridization index, which is I is equal to minus cos theta, then definitely like S character, P character, and different other concepts are supporting the hybridization. In that case, we can consider the hybridization. But if there is a significant deviation from the actual bond angle, then it is like considered that hybridization is not present. So one concept is either Drago's rule, another concept is with the bond angle, which you can deal with hybridization index SPI, which is referred as hybridization index, or you can say bond angle parameter. So whenever it is asked like in which of the following case hybridization is not possible, then you have to consider two main concepts. So Drago's rule, all of you are aware of that. In case of hydride of 15th and 16th group, except ammonia and water, hybridization is not present since bond angle data is not supported. So Drago's rule is also indirectly application of bond angle data. So if S2S, S2SE, S2T bond angle you will see. So in S2S, like bond angle is close to 92 degree. In case of S2SE, S2T bond angle is very much close to 90 degree. So here to here bond angle is varying from 92 degree to 90 degree. In PS3 bond angle is close to 94 degree, and till last if you will see it is close to 90 degree. And in case of P4 you will see bond angle is 60 degree. So definitely their bond angle data is not supporting the actual hybridization which you are counting with respect to number of sigma bond and lone pair. So in all such molecules, we are not considering hybridization. So if you have to write the answer, you just count. So your answer will be 8. All these molecules will not follow hybridization because their actual bond angle data is not supporting the hybridization. But be careful, if hybridization of any of these molecule is asked, then as per rule, you can write the hybridization. Like if it is asked hybridization of phosphorus in P4, if option is given sp3, you may write. Because in case of P4, if you draw the structure with respect to mathematical hybridization concept, there is no problem. I can write that phosphorus having 3 sigma bond and 1 lone pair. So hybridization is sp3. But if I'll consider with the bond angle data, then you can see that even if lone pair, if you even if you lone pair bond pair repulsion, you will consider bond angle will be slightly reduced from 109 degree to 28 minute. So to explain bond angle 60 degree, you cannot use hybridization concept. That's why in such molecules, we'll say there is no hybridization. So whenever hybridization index concept is incorporated or whenever bond angle data is not supporting, so, like in all such cases, hybridization is not considered. Always compare through bond angle data. If hybridization is supported by bond angle data or S character and P character concept, it's okay. If it is not supporting that way, then definitely hybridization is not considered because it is a mathematical phenomenon which is to explain the concept, which is to explain the concept. If concept is not explained, then you have to definitely skip that hybridization. So both type of questions can be asked in JEE advanced paper. They may ask that hybridization is not considered in P4 because of, then our answer will be bond angle data is not supporting it. And if it is a very routine question, they may ask like P4 has sp3 hybridization. So that statement is also considered as correct because mathematically, if you want to write the hybridization, you may write by counting sigma bond and lone pair. But if I'll go with the concept of hybridization, so it is actually considered with SPI index, which is I is referred as hybridization index. This I is basically referred as hybridization index, which is basically related to bond angle or percentage S and P character. That also we can relate with the same formula. If I'll relate with the percentage S and P character with the hybridization index, so that will also like discuss about the actual hybridization. So it is a mathematical phenomenon. It's not basically overlapping of the atomic orbitals simply. So with that way, if you deal, automatically you'll understand it's a concept where bond angle must support the like hybridization. If it is not supporting, you have to think of that hybridization is not there. Clear? So both ways it should be clear. Next question, if I'll tackle another question of same type where explanation and statement based thing I have taken. So it's given white phosphorus is lesser stable and whereas red phosphorus is more stable. White phosphorus is lesser stable, whereas red phosphorus is white phosphorus is lesser stable, whereas red phosphorus is more stable. White phosphorus exists as an individual P4 having more strained geometry, while red phosphorus has a P4 tetrahedral structure linked together. तो इसमें भी सेम कंसेप्ट है, जब हम P4 के सिंगल स्ट्रक्चर को ड्रॉ करते हैं और रेड फॉस्फोरस का स्ट्रक्चर ड्रॉ करते हैं. सो फॉर योर हेल्प आई हैव ड्रॉन द स्ट्रक्चर, ऑल्दो द स्ट्रक्चर यू कैन इजीली फाइंड आउट इन P block phosphorus family, even in NCERT book, or even if you'll follow JDL, there also you'll get the same thing. So P4, this is single unit, which you can say as a white phosphorus, and this linear polymer is referred as red phosphorus. If I'll mark it as a 3D polymer, that is black phosphorus. So this is red phosphorus. So red phosphorus is a linear polymer. In this case, you can see definitely the strain has reduced because one phosphorus phosphorus bond has cleaved and it becomes a linear polymer. So stability has certainly increased. Clear? Then to the another question where like I'm discussing about different type of bond angles. So let's consider this question first, then you understand what I'm trying to ask. So in this question, it's given like find the correct order of initial true and false in the statements. Use T is for the statement true and F for the false statement. So in this case, it is given that we are having BR bond angle at PCl3 Br2 is 180 degree. So first you will draw the structure of PCl3 Br2, and as you all know, Drago's rule I've already discussed. इसका मैंने एक वीडियो भी बना के डाला था जिनको ड्रैगोस रूल अभी ड्रैगोस रूल आई एम सेइंग बेंट्स रूल का मैंने एक पूरा वीडियो बनाया था. अगर बेंट्स रूल अभी भी आपको क्लियर नहीं है तो आप वो वीडियो एक बार जरूर फॉलो करेंगे, देन ओनली इट विल बी क्लियर टू यू. सो अभी बेंट्स रूल के हिसाब से मैं ड्रॉ कर रहा हूँ. तो मैंने आपको कंसेप्ट बताया था sp3 डिहाइब्रिडाइजेशन में जो मोर इलेक्ट्रोनेगेटिव एलिमेंट होता है दैट ऑक्यूपाइज एक्सियल पोजीशन. सो PCl3Br2 वी हैव टू ड्रॉ लाइक दिस. Okay. And in this case, it is given BR bond angle is 180 degree, which is certainly not possible. This angle is not 180 degree. So I can certainly say that bond angle will be little different than this. थोड़ा सा bond angle में definitely difference आएगा, and it is sp3d triangular bipyramidal geometry. And in this geometry, both the Cl will be in axial position. Br cannot be in axial position. So first statement is false. NO2 plus NO2 and NO3 minus having species ONO bond angle in the order. So here simply you can draw the structure. NO2 plus will be sp hybridized, in which N double bond O structure is there. So this is sp hybridized. NO2 we have odd electron species, so it has one single electron, which we can write like this. It has a bent shape. This is NO2. And once I'll write NO2 minus, so there it will be a certainly lone pair of electron like this. So these are the three structures. So lone pair repulsion will be certainly more repulsion than a single electron. So NO2 minus will have smallest bond angle, then NO2 and then NO2 plus. So this is the correct statement. Oxyacids is not produced when NCl3 undergo hydrolysis. So basically in NCl3, the concept is that there is no vacant orbital available with nitrogen. There is no vacant orbital available with the nitrogen. So water attacks with its lone pair of electron on Cl, not on hydrogen. So here how reaction takes place, that water from its lone pair of hydrolysis means attack of water as a nucleophile. Since nitrogen has a lone pair of electron and it has no vacant orbital, so attack of water is more preferred on chlorine. So once it is preferred on chlorine, then it will bond as an OH with Cl and H with nitrogen. So on hydrolysis, we get ammonia and HOCl. 3 units of HOCl and ammonia. So we definitely get one oxo acid. Since it is given oxo acid is not produced, so it is an incorrect statement. And then it is given in complete combustion of ethane, change in hybridization of carbon atom undergoes sp3 to sp, which is routine question. When it is complete combustion, CH4 will convert to CO2. And in case of CO2, hybridization of carbon is sp now, which was earlier sp3. And this is also very standard question for J advanced, where they can involve certain chemical reaction in a particular process and then change of hybridization can be asked. CH4 is sp3 hybridized and CO2 is sp hybridized. It's a very simple question, but with respect to reaction such type of things can be given. पहला क्वेश्चन था इसलिए एक्सपेरिमेंट में बहुत आसान क्वेश्चन लिया. अभी आगे इस तरह के क्वेश्चंस और डील करते हैं. नाउ अभी मैंने थोड़ी देर पहले PCl3Br2 डील करा, तो उसको थोड़ा और अच्छे से डील करने के लिए एक और क्वेश्चन लिया है. So question is now in if number of different type of bond angles in AsF3Cl2 is x basically. So that x you have to find is x. This is, or more precisely if I write, so you can also discuss the bond angles or also discuss about the bond angles. That is a basic point. So आपको x फाइंड आउट करना है। तो पहली चीज तो आपको समझ में आनी चाहिए कि AsF3Cl2 जो है वो sp3d हाइब्रिडाइज्ड है और ये ट्रायंगुलर बाइपिरामिडल शेप है। थोड़ा टाइम सेव करने के लिए मैंने स्ट्रक्चर पहले से ड्रॉ किया हुआ है और कुछ फिनोमेनन पहले से लिख दिया है जो मैं आपको पिछले क्वेश्चन में डिस्कस करके आया हूँ, तो इसलिए अभी उसमें बहुत टाइम नहीं लगाता हूँ। मेन कंसेप्ट पे आता हूँ। सो बेसिकली इफ यू हैव टू डिस्कस अबाउट द नंबर ऑफ बॉन्ड एंगल्स, तो मैंने आपको पहले एक कंसेप्ट बताना है कि टोटल नंबर ऑफ बॉन्ड एंगल्स पहले डिसाइड कर लो। सो सिंस इट इज अ sp3d हाइब्रिडाइजेशन और सराउंडिंग हमारे पास 5 एलिमेंट हैं, इनमें से कोई भी दो सिलेक्ट करोगे तो एक टाइप ऑफ बॉन्ड एंगल क्रिएट होगा। सो टोटल 5c2 बॉन्ड एंगल्स होंगे विच इज इक्वल टू 10। सो टोटल 10 टाइप्स ऑफ बॉन्ड एंगल पॉसिबल है, और बेटर टू से टोटल 10 बॉन्ड एंगल्स पॉसिबल है, नॉट से टाइप्स। सो टोटल 10 बॉन्ड एंगल्स पॉसिबल है। ठीक है। अगर ये स्टैंडर्ड sp3d हाइब्रिडाइजेशन होता, अगर ये आपका स्टैंडर्ड sp3d हाइब्रिडाइजेशन होता, तो उस केस में क्या करते हैं हम लोग, हमें पता था इसमें टोटल 90 डिग्री के 6 एंगल आते, 120 डिग्री का 3 एंगल आता और 180 डिग्री का एक एंगल आता। स्टैंडर्ड ज्योमेट्री में यही होता है। तो अगर हम sp3d स्टैंडर्ड ज्योमेट्री की बात करें तो उसमें 90 डिग्री के 6 एंगल, 120 डिग्री के 3 एंगल और 180 डिग्री का एक बॉन्ड एंगल होता है। ये स्टैंडर्ड ज्योमेट्री में ऐसा होता है। अगर ट्रायंगुलर बाई पिरामिडल ज्योमेट्री होती तो ये बॉन्ड एंगल्स आते हैं। बट सिंस हियर क्लोरीन इज इन्वॉल्व एंड क्लोरीन और फ्लोरीन दोनों आइडेंटिकल स्ट्रक्चर्स नहीं हैं, तो डेफिनेटली क्लोरीन का साइज बड़ा होने की वजह से फ्लोरीन थोड़ा सा टुवर्ड्स लाइक राइट शिफ्ट होगा, लाइक दैट यू कैन से। और फ्लोरीन, और या दूसरे तरीके से समझें तो फ्लोरीन बीइंग मोर इलेक्ट्रोनेगेटिव एलिमेंट, उसका सिग्मा इलेक्ट्रॉन डेंसिटी जो है टुवर्ड्स फ्लोरीन शिफ्ट होगी और क्लोरीन का इलेक्ट्रॉन डेंसिटी टुवर्ड्स आर्सेनिक शिफ्ट होगी। तो अगर मैं उस एंगल से थोड़ा सा समझाऊं तो थोड़ा सा वेरिएशन, ऑल्दो एग्जैक्ट बॉन्ड एंगल पे तो हम लोग डिस्कशन कर भी नहीं रहे। तो यहाँ पे जो बॉन्ड पेयर होंगे वो टुवर्ड्स आर्सेनिक होंगे और यहाँ पे जो बॉन्ड पेयर होगा वो टुवर्ड्स फ्लोरीन होगा। तो क्लोरीन आर्सेनिक बॉन्ड पेयर का रिपल्शन फ्लोरीन आर्सेनिक बॉन्ड पेयर से ज्यादा लगेगा, इसलिए जो फ्लोरीन वाला बॉन्ड है वो टुवर्ड्स फ्लोरीन शिफ्ट हो जाएगा। ठीक है। जो दोनों वर्टिकल फ्लोरीन है उसका फ्लोरीन के साथ एंगल डिफरेंट है और क्लोरीन के साथ एंगल डिफरेंट है। तो पहले दो टाइप के एंगल तो यही हो गए, FASF, एक एंगल ये डिफरेंट होगा। और वर्टिकल वाले से लिख दूं, अगर मैं अगर और प्रिसाइसली लिख दूं तो उसको एक्सियल लिख देता हूँ और इसको इक्वेटोरियल लिख देता हूँ, तो आप आसानी से पहचान जाओगे। सो FA वी आर रेफरिंग फॉर एक्सियल बॉन्ड और FE आई एम रेफरिंग फॉर इक्वेटोरियल बॉन्ड। तो सबसे पहले हमने एक F एक्सियल आर्सेनिक और F इक्वेटोरियल के बीच का एंगल लिखा, जो नीचे और नीचे वाला फ्लोरीन और ऊपर वाला फ्लोरीन सेम ही एंगल बनेगा। दूसरा पॉसिबल एंगल जो मैं लिखूंगा वो होगा फ्लोरीन एक्सियल देन आर्सेनिक एंड देन क्लोरीन इक्वेटोरियल। ऑल्दो वो इक्वेटोरियल ही है, एक्सियल है ही नहीं, तो लिखने की जरूरत नहीं है। ये दूसरा बॉन्ड एंगल हो गया। ठीक है। तीसरा पॉसिबल बॉन्ड एंगल जो है वो है एफ एक्सियल का आर्सेनिक के साथ ज्वाइन करते हुए एफ एक्सियल का ही बॉन्ड एंगल। दिस इज द थर्ड वन पॉसिबल। ठीक है। सिंस ऊपर फ्लोरीन एक्सियल और नीचे वाला फ्लोरीन एक्सियल आइडेंटिकल है, तो ये बेसिकली 6 तरह, लाइक बेसिकली 5 तरह के बॉन्ड एंगल कवर हो गए। अगर ट्रायंगुलर बाइपिरामिडल की ज्योमेट्री के पॉइंट ऑफ व्यू से स्टडी करोगे तो फ्लोरीन एक्सियल का पहले तीन इक्वेटोरियल वाले बॉन्ड के साथ एंगल देखेंगे तो टोटल 6 बॉन्ड एंगल वहां पे कवर हो रहे थे। तो 7 बॉन्ड एंगल में से 3 डिफरेंट है। इतना समझ गए। अब मुझे केवल 3 एंगल और डील करने हैं। तो सबसे पहला एक एंगल जो आपको डिफरेंट समझ में आ रहा होगा, आसानी से समझ जाओगे, वो है क्लोरीन आर्सेनिक क्लोरीन। दिस विल बी अ डिफरेंट बॉन्ड एंगल। एंड देन क्लोरीन आर्सेनिक एंड फ्लोरीन इक्वेटोरियल, ये भी डिफरेंट बॉन्ड एंगल होगा। और ये दोनों एंगल सेम होंगे, क्लोरीन आर्सेनिक फ्लोरीन एक और क्लोरीन आर्सेनिक फ्लोरीन दोनों, वो दोनों आइडेंटिकली डिस्ट्रीब्यूटेड होंगे, सिमेट्री की है। सो बोथ विल बी ऑफ सेम टाइप। तो यहाँ पे अगर डिफरेंट टाइप ऑफ बॉन्ड एंगल्स की स्टडी करेंगे तो इट विल बी 5। क्लियर। आई होप क्लियर, क्योंकि पिछले क्वेश्चन में मैंने आपको सिर्फ डिफरेंट एंगल की बात करी थी, वो एंगल मेजर करना भी सिखा दिया है। बेंच टूल का कंसेप्ट है, अगर आप मिस कर रहे हो तो मैंने आपको बताया बेंच टूल का एक स्पेशल वीडियो मैं ऑलरेडी डाल चुका हूँ कंसेप्ट बिल्डर के नाम पे, आप उसको फॉलो कर लीजिएगा, आपका ये पार्ट क्लियर हो जाएगा। नाउ कम टू द अनदर क्वेश्चन, जहाँ पे प्लेनैरिटी को लेके बहुत सारे क्वेश्चंस आते हैं, तो मैंने एक ही क्वेश्चन में कंसेप्ट इनकॉर्पोरेट करने की कोशिश की है। अगर इस तरह के स्ट्रक्चर्स नहीं पता है तो फिर सारे तरह के स्ट्रक्चर स्टडी करने, तो क्वेश्चन इज हाउ मेनी ऑफ द फॉलोइंग इज अ प्लेनर। तो लाइक सबसे पहले स्पेशल स्ट्रक्चर्स का केस है बेसिकली। तो आई होप H2O2 आप सब समझते हो, दिस इज हाइड्रोजन पर ऑक्साइड, जिसका ओपन बुक स्ट्रक्चर होता है, जो कि नॉन प्लेनर है। इट हैज ओपन बुक स्ट्रक्चर। और अगर आपको थोड़ा सा ध्यान दिलाऊं तो इसकी टॉटोमरिक फॉर्म भी एग्जिस्ट करती है, वो पार्ट भी अगर हम चाहें तो यहीं पे डील कर सकते हैं। दिस इज टॉटोमर। सो स्ट्रक्चर ए एंड बी आर बेसिकली टॉटोमर्स ऑफ ईच अदर। वो पार्ट भी यहीं पे एक ही बार में लिखे दे रहा हूँ। सो दिस इज ओपन बुक स्ट्रक्चर, सो सर्टेनली नॉन प्लेनर। इसके बाद मैंने जो तीन मॉलिक्यूल लिए हैं वो ब्रिज बॉन्डिंग के बहुत स्टैंडर्ड एग्जांपल हैं। तीनों तरह की ब्रिज बॉन्डिंग आप चाहो तो रिकॉल करा देता हूँ, अगर आपको अच्छे से आता है तो बहुत पॉइंट नहीं रिक्वायर्ड है। अदरवाइज बॉन्ड लेंथ बॉन्ड स्ट्रेंथ पैरामीटर भी आप बहुत इंपॉर्टेंट होते हैं। सो इसमें स्ट्रक्चर ड्रॉ कर देता हूँ, जिन्हें आइडिया नहीं होगा वो फिर बाद में डिस्कस कर देंगे, या ब्रिज बॉन्डिंग अगर होगा तो मैं बाद में लास्ट में बता दूंगा इफ इट इज योर डाउट। सो हमने पहले B2H6 का स्ट्रक्चर लिया। सो B2H6 के ये दोनों बॉन्ड टू सेंटर टू इलेक्ट्रॉन बॉन्ड है। इसके बाद हमने एक बोरॉन का इलेक्ट्रॉन, एक हाइड्रोजन का इलेक्ट्रॉन, फिर एक बोरॉन और एक हाइड्रोजन का इलेक्ट्रॉन लिया। यहाँ पे अगर ट्रिक की तरह समझना है, किसी को याद करना है या नहीं याद करना है कि हम कैसे ज्यादातर स्ट्रक्चर बनाएंगे, तो ध्यान रखना है यहाँ बोरॉन एंड हाइड्रोजन बोथ हैव नो लोन पेयर। तो आप एक ट्रिक की तरह से समझो कि अगर सेंट्रल एटम और सराउंडिंग दोनों के पास लोन पेयर नहीं है, तो यहाँ जो टाइप ऑफ बॉन्ड बनता है वो बनता है थ्री सेंटर टू इलेक्ट्रॉन बॉन्ड। इसी को हम लोग बनाना बॉन्ड भी बोलते हैं, ब्रिज बॉन्ड भी बोल सकते हो। So in this case, boron, hydrogen, boron, these three centers and two electron of boron and hydrogen forms one three center two electron bond, and another boron, hydrogen and boron with electron of one boron and another hydrogen. This is also three center two electron bond. Since it is a three center two electron bond, then hybridization of this boron becomes sp3, and now it is a non-planar molecule. Okay. Then if I'll go to Al2Cl6, अब ये देखो दूसरा ब्रिज बॉन्ड का केस है जो थोड़ा सा ट्रिकी है। अब क्या हो रहा है कि सेंट्रल एटम के पास तो लोन पेयर नहीं है, बट सराउंडिंग एलिमेंट के पास लोन पेयर है। सो जब सेंट्रल एटम के पास लोन पेयर नहीं होता है और सराउंडिंग एलिमेंट के पास लोन पेयर होता है, इन दैट केस वी फॉर्म अ बॉन्ड विच इज कॉल्ड थ्री सेंटर फोर इलेक्ट्रॉन बॉन्ड। तो यहाँ पे इंपॉर्टेंट पॉइंट अगर मार्क कर दूं तो यहाँ पे एल्यूमिनियम हैव नो लोन पेयर, बट क्लोरीन हैव लोन पेयर। अब इसको ट्रिक की तरह समझना है, इसलिए मैंने कहा अगर आप कंसेप्ट जानते हो तो याद बहुत कम करना पड़ेगा। दोनों के पास लोन पेयर नहीं है तो थ्री सेंटर टू इलेक्ट्रॉन बॉन्ड। सेंट्रल एटम के पास लोन पेयर नहीं है, सराउंडिंग एलिमेंट के पास लोन पेयर है, तो ये बॉन्ड हो जाता है थ्री सेंटर फोर इलेक्ट्रॉन बॉन्ड। यहाँ किसी भी एलिमेंट के साथ इस तरह की बॉन्डिंग आएगी, सेम रिजल्ट आने वाले। तो अगर आपने एक स्ट्रक्चर ठीक से समझ लिया तो सारे ब्रिज बॉन्ड आप एक बार बना पाओगे, नथिंग टू लर्न। सो दिस इज थ्री सेंटर फोर इलेक्ट्रॉन बॉन्ड। तो अब यहाँ पे अगर बॉन्ड बनाऊंगा तो क्लोरीन के साथ एक बॉन्ड डायरेक्ट और एक बॉन्ड कोऑर्डिनेट बॉन्ड बनेगा। इसीलिए हमने तीन सेंटर लिए, एल्यूमिनियम क्लोरीन एल्यूमिनियम, और चार इलेक्ट्रॉन लिए, एक कोवेलेंट बॉन्ड बनाने के लिए और एक कोऑर्डिनेट बॉन्ड बनाने के लिए। सो थ्री सेंटर फोर इलेक्ट्रॉन बॉन्ड। Here also we get one bond, and then this is coordinate bond. So this is three center four electron bond. Again, you can see that hybridization of aluminum becomes sp3, so it is tetrahedral, again non-planar. ठीक है। थर्ड केस है I2Cl6। ये भी ब्रिज बॉन्डिंग का स्पेशल केस है, बट इसको थोड़ा डिफरेंट टैकल करना सीखना है। अब I2Cl6 में क्या हो रहा है, दोनों के पास लोन पेयर है। When lone pair of electron is present with both central as well as surrounding element, then in that case, what will happen? It is again three center four electron bond, but it becomes planar. So here iodine and chlorine both have lone pair. So if central atom and surrounding atom both have lone pair, then in that case again bonding is three center four electron bond. And since it is a three center four electron bond, so again we can form a covalent bond and a coordinate bond, then again a covalent bond and a coordinate bond. Now, since lone pair of electron is available with both central and surrounding element, so it will look like this. Because of which hybridization of iodine gets changed. Now it is 4 sigma bond and 2 lone pair. And hybridization becomes sp3d2. Geometry becomes a square planar, and this molecule becomes planar. Remember it as a trick. Whenever bridge bonding is there, both have no lone pair, three center, two electron bond. hybridization mostly reaches to sp3, non-planar structure is possible. When it is three center, four electron bond and surrounding element has lone pair of electron, again sp3. If central and surrounding both have lone pair of electron, check it very carefully. Bonding is three center, four electron bond, but it can be sp3 d2 hybridization square planar, right? So this becomes planar, means one option we have eliminated. Question is asked, how many of the following are planar? So one option is I2Cl6. Then comes to SiO2. This is also very important concept. And remember it as a rule now. As I said in inorganic chemistry also, like you have to learn much when you don't know the proper concepts. If you know the most of the concepts, then there is very minimum learning. So in case of SiO2, what exactly happens? Rule is like whenever we have to create a pi bond. So it is required that we must have a 2p orbital. So in SiO2, bonding is not like CO2. So it is actually a 3D silicate and it exists in a polymeric form. This is 3D silicate in which silicon is sp3 hybridized and one silicon is bonded with four oxygen and all four oxygens are shared between two silicon. So just a little structure I'm drawing for you. So it is SiO2 in which all the oxygens are shared basically. So like that structure is formed as a 3D silicate. And definitely all of you have learned about the silicate, so I'm not going in much detail. If it is a difficulty, then we may discuss in some another lecture where silicates will cover up, especially for the advanced. So like that, we can form a three giant structure. So it's 3D silicate. Definitely it is three-dimensional. Now there is a tricky case where we are using 2D silicate. This term itself is confusing. Whenever I'll write 2D silicate, it looks like we are talking about two dimension, but be careful. All the silicates are three dimensional because silicon is sp3 hybridized in all the cases. So this is again non-planar structure. So if I deal 2D silicate, so mostly it is example of like say sheet silicate or a specific type. So I can write it is SiO3 minus whole n kind of structure. I'm not drawing much structure, but it is certainly non-planar. As I said, silicate we'll discuss on different part because if I'll complete silicate, then that complete lecture will go for that. Next one is BeCl2 whole twice, and this you can definitely understand now. So if we have beryllium and we have two units, and we are using basically uh, four chlorine, so Be2Cl2 is like BeCl2 whole twice is like this. Now you can notice again trick what I said that beryllium has no lone pair of electron, chlorine has lone pair of electron. So one covalent bond and other coordinate bond. So type of bond will be three center, four electron bond like this. But since boron has formed only three bonds, so it is sp2 hybridized. This one is also sp2 hybridized. Okay. These two are sp2 hybridized. So this molecule is certainly planar. So here it is, you can say three center, four electron bond. Three center, four electron bond. Three center, four electron bond. And this molecule is planar. Why it is planar? Because beryllium is now sp2 hybridized with three sigma bond. So okay, this is the another planar molecule which you can mark this one. So it becomes two planar till now. Then it's given BeCl2 whole N. Whole N means we have to draw polymeric form. So in polymeric form, it is continuous three center two electron bonds. So then it becomes sp3 hybridized and non-planar. If I write BeCl2 whole N, then it will look like this. One covalent bond, another coordinate bond, one covalent bond, another coordinate bond, likewise. Clear? like this. So it is now sp3 hybridized. So it is non-planar. It's a very genuine question, which is like most expected question for J advanced paper. Next, if I'll go for like it is CLF3. This is again a tricky question. Almost every one of you know the structure. So CLF3 will be T shape actually. Or if I, precisely it is like this. Bond angles are not actually 90 degree because of lone pair repulsion. Its bond is slightly shifted towards chlorine. So you can say hybridization is sp3d and it's T shape, but T can be written on a plane. Lone pair of electron we don't consider for the like geometry, or better to say like shape of the molecule. So it is certainly T shape and it's planar. So sp3d T shape and it's planar.
सर वहाँ एफ एटम लगेंगे.
So be careful, like whenever we say lone pair of electron is there, that you don't consider for the particular geometry, and the 2Cl will be like this. So ClF3 is basically T shape like this. So sp3d T shape and it's a T shape, so it is certainly planar. So all the linear and like planar geometries are in the planar category. So ClF3 is planar. Mostly such type of things are skipped. So this becomes the third molecule, which is planar. Then another molecule I have taken, which is also more related to organic chemistry. This is allene basically. So this is also an important structure, which I'll discuss in the same question itself. I'm trying to cover up most of the concept in a single question itself. So this is basically allene, which all of you know from organic that it has a non-planar structure. In out system must be read in the organic. But here, since I'm dealing it in the inorganic chemistry, so you must be aware of the orbitals involved in this particular structure. So this is the form. And before writing anything, all of you are aware of it is non-planar. Hydrogens are in two different planes. Now, if I have to explain it, it is sp2 hybridization, it is sp hybridization, it is also sp2 hybridization. So if anyone will look after the hybridization only, it will feel like that it should be a planar one, but it is actually not a planar structure because pi bond is formed by pure orbitals. Pi bond formed by pure orbitals. So whenever you predict a structure of a molecule, you must be aware of the planarity and non-planarity of the structure. So in this case, like if I draw this molecule like this, and I'll consider, let us say, z-axis as internuclear axis. And since it is sp3d, since it is sp2 hybridization, so for sp2 hybridization, we need one s and two p orbital. So s and pz is now fixed. If I'll fix px orbital over here, then it will be in a plane of xz plane, which you can easily think of because we have used the orbital pz and px. So their plane will be xz plane. And once xz plane has used for the sigma bond arrangement, so if I draw it, this is xz plane. This is triangular planar system, which I'm showing that it is an xz plane. Okay, like this. After this, like the next carbon is now sp hybridized. So sp hybridized means what are the and now to form a pi bond, I am using pure p orbital. So here py orbital of this and py orbital of this has used to form a pi bond. Clear? Now, for the another sigma bond which we are discussing, this is again sp hybridized. So for this sp hybridized, the orbitals involved should be s and pz, and then Since pz is used in the sigma bond, py has already used in one pi bond, so another pi bond will be formed by px and px overlapping. This is the another pi bond formed. Then this carbon is now sp2 hybridized, and now orbitals used will be s, pz, and py, because px is used in the pi bond. So this part goes in yz plane. So certainty you can say that this molecule is non-planar because one part is in xz plane, another part is in yz plane. And if you want to show this yz plane, then this one is in the different perpendicular plane. And part of it we use in stereoisomerism also. That's why I've explained it little detail, because in future when we'll discuss about stereoisomerism, then it will be need. So both the hydrogens are in different plane. Okay. So with respect to organic, if I'll draw, then all of you can say it will look like this, in which we are using two different planes. So if these two hydrogen are on the plane of this paper or plane of the sheet, then this edge will be inside the board and this edge will be outside the board. Very much clear. So this molecule is certainly non-planar. And its next member will be planar, which I am leaving for you. You can like predict the structure in the similar form. Then it will be again planar. So the question is asked, how many of the following are planar? So our answer is 3 now. Clear? Then we go to the next question, uh, where it's given like find the hybridization of xenon. Next question is find the hybridization of xenon in the reactant and product on hydrolysis of XeF6. Also consider partial hydrolysis product. So I am relating the question little with P block. So I have written the equations for you. If you know that, it's good, because in actual question reactions won't be given. As of now, I have written the equations for you. आप उन्हें डायरेक्टली फॉलो कर सकते हो। अगर आपको पहले से क्लियर है तो आप प्रोडक्ट लिख लीजिए, नहीं क्लियर है तो मेरे हिसाब से लिख लीजिए, बस आपको सिर्फ हाइब्रिडाइजेशन मार्क करना है। सो इन XeF6 हाइब्रिडाइजेशन इज sp3d3 एंड इट्स अ इंपॉर्टेंट मॉलिक्यूल, जो मैं आपको अलग से बताना चाहता हूँ। So it is basically capped octahedron or distorted octahedron. And in this case, lone pair of electron is present in stereochemically inert orbital, because that does not define its standard geometry. So this is the position of lone pair of electron. And this lone pair is present in stereochemically inert orbital. And the concept is, since lone pair of electron is like, if I discuss about the orbital, so energy difference is much higher. So here, like for xenon, valence shell is fifth cell. So we are going to use 5s, 5p, and 5d for hybridization. And since it is sp3d3 hybridization, so 5d orbitals we are using 5d x square y square, 5d z square, and 5d xy. These are the d orbitals which I am using. So 5s, 5d, 5p, and 5d have much difference in their energies. So much higher difference in. So it is also equivalent to the same concepts, and hybridization is a mathematical concept. We are doing hybridization just by counting 6 sigma bond and 1 lone pair. But here also the problem is that 5s orbital has much more different energy than the 5d. So they are not almost equal energy atomic orbitals. So hybridization is not so perfect. Once hybridization is not so perfect, so this lone pair is very much close to nucleus and it will not give that much repulsion as much a lone pair has to perform. That's why we are using the term. Its geometry is distorted octahedral. Distorted octahedral. But it is distorted octahedral, or we can say use sometimes capped octahedron. Rotation is sp3d3. and lone pair of electrons is presented stereochemically in that orbital. Post that, take all our routine question. XeOF4 will be sp3d2 hybridization, square pyramidal. XeO2F2 will be sp3d hybridization, C-sharp. And XeO3 will be sp3 hybridization, pyramidal shape. So just for your quick reference, I'm just drawing the structure. So XeOF4 will be like this. XeO2F2, just remember the Bend's rule because oxygen is more electronegative element, so it should be in equatorial plane. So this is your XeO2F2, C sharp. So this is square pyramidal, sp3d2. This is C sharp, sp3d. And then XeO3 will be sp3 hybridization with 3 sigma bond and 1 lone pair. This is also pyramidal shape and it is an explosive, or you can say right triangular pyramidal. Triangular pyramidal with sp3 hybridization. So sometimes such type of questions are where like a reaction is involved and then hybridization, different type of bond angle, bond parameters can be asked. So such type of questions are also like equally probable in the examination. Now some more organic particle involved during the hybridization thing. So predict the hybridization of carbon in the following. Consider only carbon-carbon bond cleavage. First case it is given homolysis, second case it is given homolysis, and third case it is given heterolysis. So I wish you are aware of that homolysis and heterolysis means we have to go for homolytic bond cleavage and heterolytic bond cleavage. Here we will also discuss about the hybridization of single electron, or you can say a radical case, unpaired electron case. So we are discussing that kind of hybridization also here in the similar question. So once I'll do the first case where I'm doing homolysis of CS3, so it will form CS3 free radical. Okay, so it will form CS3 free radical. So with this reaction, your product formed is CS3 free radical. And one important thing is like unpaired electron is present or unpaired electron is highly energetic. And since you all know that for hybridization, electronic orbital should be almost of equal energy. So in this case, electron is not involved in the hybridization. So once we'll discuss about the structure of CS3, we can write very much close to triangular planar in which one single electron is available. And we can write the hybridization is closest to sp3, closest to sp2 because there is no significant repulsion of the single electron sp2 and we can write the shape as triangular planar. This is triangular planar. Now if I do the same thing for CF3 homolysis. So in this homolysis, again, like homolytic bond cleavage takes place, a free radical will form CF3 radical. So now we get CF3 radical. And in case of CF3 radical, since fluorine is one of the most electronegative element, so that creates quite high delta positive charge on carbon, because of which it will pull its single unpaired electron more close to the nucleus, and then it becomes lower energy and it participates in the hybridization. So when a more electronegative element is involved with the carbon, it creates significant delta positive charge on carbon, because of which it can pull its unpaired electron more towards the nucleus, and then it can participate in the hybridization. So here it will be sp3 triangular pyramidal shape, or simply pyramidal also you can write triangular pyramidal shape. This is the possible structure CF3 radical. Okay. So here unpaired electron is participated in the hybridization. And the third possible condition where we are using a hydrolysis thing. So hydrolysis things mean we can go for carbocation and carbanion formation. So their hybridization is very much clear, which is a routine question. Most of you will be aware of it. So during this hydrolysis, we get CS3 cation and CS3 minus. So we actually get CS3 plus and CS3 minus. Don't think about how such reaction will take place. It's given in the questions. We have to go in a similar manner. So in case of CS3, it is case of 3 sigma bond and one vacant p orbital, which is perpendicular to the molecular plane. Hybridization will be sp2, triangular planar. So it is CS3, so again it's having a lone pair of electron, 3H shape. So like when we have to frame a question, most of the time we can write which of the following can have identical shape, which of the following can have identical hybridization. So likewise, we can create different type of questions. So this is sp3 triangular pyramidal shape again, one lone pair and 3 sigma bond. Okay. Now we can discuss about the hydrolysis part of typical carbides. So this is another question for you. It's given based on the hydrolysis products of the following, deduce the structures of the following. So most of the carbides and one nitride I have used basically. So here you have to discuss about these ionic compound structures. And I wish all of you are aware of the fact that during hydrolysis, more electronegative element has been given H and electropositive element has given OH. So just if you apply simple balancing thing, then also you'll be able to understand what's the possible structure. So let's say calcium carbide thing I'm dealing. So if I've used two OH, I have to use two OH H. So it's basically balanced by two water. Since it is given C2H2, I can definitely write its structure. It is this acetylene. And once this acetylene is like the product, that means anion of the reactant is clear now. It will be C2 minus. So definitely if I have to reduce the structure of this carbide, which is an ionic compound, so structure will be calcium 2 plus and carbide minus, because during hydrolysis, carbon has got H. So to draw the structure, remove the H and connect with the ionic bond of calcium. So this is the answer. Next part, if I do for the magnesium carbide, similarly, I'll deal the structure again. So in case of magnesium carbide, since the product is propyne, so it is CH3, C triple bond CH, and 4H we have added through water. So definitely the structure will be magnesium 2 plus with 2 units, and the charges will be like this. This is the structure possible. In case of magnesium nitride, we all know Mg3N2. So since ammonia has formed, that means all H are there. So we are basically using 3 magnesium hydroid and 2 ammonia and definitely 6 water. So definitely inorganic chemistry questions are nowadays more linked with mole concept. So balancing is equally important. It can be as that how many moles of water is consumed per mole of ammonia and similar kind of questions. So since it is again an ionic compound, so nitrogen, if all the H will remove, it will form nitride ion. Sorry. So it will be N3 minus, and to balance the charge, we'll have Mg2 plus. So 3 units of magnesium and 2 units of nitride. This is again an ionic bond. In case of aluminum carbide, again same thing. We are getting CH4. So that means we are having carbon 4 minus directly. So we can write 4Al3 plus and 3 units of C4 minus. And in case of beryllium carbide also, we are getting methane. So they are also referred as methanides. So 2Be2 plus and C4 minus. These are the different structures of carbide. Most of them are ionic compounds, or better to say all are ionic compound in this particular question. So whenever such type of questions are there, just see the hydrolysis product. And when actual question will be asked, they'll not give you the hydrolysis product. Since I'm dealing these questions and I'm focusing on chemical bonding thing, that's why I'm giving you hint in the starting itself. But in the actual question, be prepared that here onwards you have to learn these reactions also, or you have to learn the concept. Although there's not much learning, simple technique I have already told you. In hydrolysis, what exactly I have done? Electronegative element was carbon, it's given H, so it is C2 and calcium hydroxide. So first write the hydroxide part first. Once you write the hydroxide, you'll understand how many OH are used. Then rest of the H you will wind up with the more electronegative element. Automatically you will get the structure. Need not to learn. So calcium hydroxide formula all of you can write CaOH whole twice. दो OH जोड़ दिए. दो एच जोड़े तो दो एच जोड़ने पड़ेंगे, C2H2। मैग्नीशियम हाइड्रोक्साइड फॉर्मूला इज MgOH होल ट्वाइस। लेफ्ट हैंड साइड में दो मैग्नीशियम है, बैलेंस करने के लिए 2 MgOH होल ट्वाइस लिया। चार OH जोड़ा है तो चार एच जोड़ना पड़ेगा, तो फॉर्मूला हो गया C3H4। समझ में आया ट्रिक? तो एक बार अगर आपने एनायन लाइक हाइड्रोक्साइड सही फॉर्मूला लिख लिया तो ऑटोमेटिकली कैटायन के स्ट्रक्चर पे भी आप ठीक से पहुंच जाओगे। क्लियर नाउ? नेक्स्ट चले। Then come to the orbital overlapping thing, which is also a routine question. So just write down the thing. Find the internuclear excess in the following sigma bonds. So one sigma bond is given. Sigma bond is given. That means you have to just remember that internuclear excess should be the one जिसके along overlapping हो रही है. So एक s orbital एक px लिया है तो it is along the x axis. दोनों px लिए हैं, that will also be along x axis. It is z, so it should be z axis, and if it is y, so it should be y axis. बहुत बेसिक क्वेश्चन है, सिर्फ फंडामेंटल कंसेप्ट जानना था। एक बार लिख दिया है। तो स्टूडेंट्स इस तरह के क्वेरीज डाले थे तो मैंने आपको बता दिया। देन टू द नेक्स्ट क्वेश्चन नाउ, लिटिल ट्रिकी क्वेश्चंस वी आर डिस्कसिंग। So it's given which of the following statement is are correct for the following compound. I have taken SCl2OCS3 whole twice and SF2OCS3 whole twice. So again the question of Bend's rule. So since sulfur is there, we have two sigma bond, two lone pair. As per the electronegativity, we have to set among chlorine and oxygen and fluorine and oxygen, there is difference of electronegativity. So chlorine atoms occupies equatorial position in the case one. So among chlorine and oxygen, oxygen is considered to be more electronegative element. So if I draw SCl2OCS3 whole twice, so OCS3 must be in axial position. There will be a lone pair of electron and the 2Cl will be in equatorial position. This is the possible structure for SCl2OCS3 whole twice. And then SF2OCS3 whole twice I'll take, then the fluorine is more electronegative. So they must be in axial position and OCS3 must be in equatorial position. These are the different structures. After that, you can easily answer. So OCS3 groups are, and both the cases occupies different positions, right? So OCS3 group, both the cases occupies the same position. So it is different. Definitely, it is not correct. Cl atom occupies its equatorial position in case of 1 and F atom occupies its equatorial position in case of 2. So first part is correct. Rest half is incorrect. Cl atom occupies its axial position in case 1 and F atom occupies its equatorial position in case 2. That is also incorrect. That's given Cl and F atom occupies either axial or equatorial position in case 1 and 2 respectively. So that is also not correct. So all the statements are incorrect. The correct statement is Cl occupies its equatorial position and fluorine occupies its axial position in these two structures. Or with respect to OCS3, if I write, then in the first structure, OCS3 is in axial position, and in second structure, OCS3 is in equatorial position. Then we'll discuss little more about percentage S character thing when we have to discuss about the bond parameters spatially. So another question is select the incorrect statement about N2F4 and N2H4. So N2F4 and N2H4 structure if you'll write, so but basically it is 4 fluorine bonded with nitrogen and both have lone pair of electrons. And in N2H4 it is like this. So these are the possibilities. Okay. So it's given if N2H4 d orbitals are contracted by the electronegative fluorine atom, but d orbital contraction is not possible in H atom and N2H4. So be very careful. It's just the option given to make you fool. Mostly like people are just applying directly explanation thing. So nitrogen and fluorine both don't have d orbital. So there is no possibility of d orbital contraction. So certainly it is incorrect. Then it's given Nn bond energy, N2O4 is more than Nn bond energy, N2H4. So basically concept is like whenever you have to create a stronger bond, so the concept is More electronegative element prefers an orbital of lesser s character. You don't know the concept, so write the concept. The concept is lone pair occupies orbital of more s character, orbital of s character, and more electronegative element occupies orbital of less s character. Be careful. If s character increases, electronegativity increases. This is a different concept. There are two different things which we are discussing. If a more electronegative element is forming bond, then it will form bond with an orbital which have lesser s character. So if I'll discuss NF2, then among nitrogen fluorine bond, percentage s character will be lesser than or better, so decrease as compared to NN bond. So here NN bond percentage s character will increase, and if percentage s character will increase, then this bond will become more stronger. Okay. So NN bond energy is N2O4 is more than NN bond energy in N2H4. So I hope you have understood the concept. In NH bond, percentage S character will be higher than the NF bond, definitely. So here NN bond energy S character will be decreased because both are more electronegative than hydrogen. So here percentage S character will decrease. So if I'll compare bond energy of NN bond, so it will be higher for N2F4 than N2H4. I wish you understood the concept. And then NN bond length. So you know that bond strength and bond length are inversely proportional concepts. So bond is inversely proportional to bond strength. Although in F2, Cl2, Br2, I2, it is little different. That's a question of P block. So be careful at that position. Rest all most of the cases, bond length and bond strength are inversely proportional, or it is inversely proportional to bond order also, same thing. So if NN bond length in N2F4 is, so it is certainly lesser than N2H4, so third option is also incorrect, then automatically fourth will be correct. So 1 and 3 are incorrect statement. Answer will be B. Clear? So just two concept, lone pair of electron occupies its orbital of more s character and more electronegative element occupies its orbital of less s character. With respect to that, we can compare the bond length or bond strength thing. Both the thing parameters can be easily discussed, right?
सर ऐसे पी ब्लॉक के लिए नहीं होगा ना?
हाँ,
बहुत
पी ब्लॉक में एक स्पेशल केस बस मैंने बताया F2 Cl2 Br2 I2 का केस लोगे, वहां थोड़ा केयरफुली हैंडल करना होता है. बॉन्ड लेंथ पैरामीटर या बॉन्ड स्ट्रेंथ पैरामीटर अगर एलिमेंट्स के बीच में डिस्कस करना होता है तो इट इज लिटिल ट्रिकी. वो हमें फैक्चुअल डेटा से स्टडी करना चाहिए. कंपाउंड्स लिखे होंगे तो बहुत कम चांसेस होते हैं गलत हो. सो लाइक अगर एग्जाम्पल लिखना है तो मैं इसका एग्जाम्पल लिखे देता हूँ. बॉन्ड लेंथ अगर आप F2 Cl2 Br2 और I2 कंपेयर करेंगे तो बॉन्ड लेंथ ऑर्डर ये आता है, लेकिन ये बॉन्ड स्ट्रेंथ ऑर्डर एग्जैक्टली डिफरेंट है. अभी मैं फैक्ट्स वाली बात लास्ट में आपको एक बार बताता हूँ, थोड़ा सा लेक्चर कंप्लीट कर देता हूँ. Then I'll tell you how to remember the facts and what are all things which you have to learn. वो भी मैं बुक खोल के एक बार मैं एनसीईआरटी से दिखाता हूँ या जेडीडी से चाहोगे तो जेडीडी से बता दूंगा. सो बॉन्ड स्ट्रेंथ के केस में अभी हमें क्या करना है कि बॉन्ड स्ट्रेंथ Cl2 की हाईएस्ट होती है, देन Br2 एंड देन F2 एंड I2. एक्सप्लेनेशन लिखना है, देन वी कैन आंसर. फ्लोरीन में लोन पे रिपल्शन सिग्निफिकेंटली हायर हो जाता है जो उसके बॉन्ड को ब्रेक करने में आसानी करता है, तो हमें रिलेटिवली कम एनर्जी रिक्वायर्ड होती है, इसलिए F2 की बॉन्ड एनर्जी सिग्निफिकेंटली डिक्रीज कर जाती है. बाय दैट टाइम यू डोंट नो द फैक्ट, तब तक आप आंसर नहीं कर सकते. ठीक. नाउ वी कम टू द लाइक डायरेक्ट क्वेश्चंस जहाँ पे हम लोग बॉन्ड लेंथ बॉन्ड स्ट्रेंथ पैरामीटर डील करते हैं. डायरेक्ट क्वेश्चंस भी हो सकते हैं या इनडायरेक्ट क्वेश्चंस भी हम लोग ले सकते हैं. ठीक है. सो लेट्स डिस्कस दिस क्वेश्चन फर्स्ट. So it's given compare CO bond length and the first I have asked number of OO bond length in the following cases. तो OO bond length अगर हमें डिस्कस करना है तो सिंपली बॉन्ड ऑर्डर पैरामीटर बस डायरेक्टली अप्लाई करिए. So if I compare bond order, so it will be 2 here. This is KO2, ionize it, so it's K plus and O2 minus. With O2 minus, you can easily predict it is superoxide ion. And once you get it as superoxide ion, then two things you will automatically understand. Bond order is 1.5 oxide ion. Bond order is 1.5 and it is paramagnetic with one unpaired electron. BaO2 is superoxide, like peroxide, so it is can be written as Ba2 plus O2 2 minus. From this, you can easily predict it is peroxide ion. Here, bond order will be 1. In this case, you can also ionize it as O2 plus AsF4 minus. So here, bond order is 2.5. And since I've already told you that bond order is inversely proportional to bond length, definitely you can answer. Shall I leave the answer? So in this case, if I write the bond length, so it is highest for PaO2. Next one next it is O2, and finally it is O2 ASF. Next case, I'm dealing it CO bond length in the following. So this is also important case because in case of CO plus bond order is 3.5. This is important, which should be known to you. If you simply solve with MOT, it is not the correct case because here you have to draw a different energy diagram for CO plus. I'll try to like explain in some another video possible because that itself is a bigger question. But by that time it is not calculated या आपने तब तक ऐसा सवाल कभी नहीं करा है. तो remember that bond order for CO plus is 3.5. CO आप आसानी से निकाल लोगे. Bond order is 3 over here. CO2 is also clear here. Bond order is 2. Then as special case carbonate ion. जब भी इस तरह का केस आएगा तो हमें रेजोनेटिंग स्ट्रक्चर ड्रॉ करके काउंट कर लेना है. सो इफ यू विल सी द रेजोनेटिंग स्ट्रक्चर यू कैन इजीली सी कि जो पाई बॉन्ड है वो तीनों ऑक्सीजन में इक्वली डिस्ट्रीब्यूटेड है और एक सिग्मा बॉन्ड सब जगह प्रेजेंट है. तो इफेक्टिव अगर बॉन्ड लिखना चाहेंगे तो इट इज 1+1/3. और 1+1/3 वन सिग्मा बॉन्ड इज प्रेजेंट एट ऑल द पोजिशंस and one third of pi bond is distributed at 3 positions, so it is 1+1/3, which we can write as 4/3. So bond order is 4.3, which is certainly less than 2. ठीक है. इसी में चाहे तो अभी मैं एक एसीटेट आयन का केस और ऐड कर सकते थे तो ये क्वेश्चन थोड़ा और ट्रिकी हो जाता है. एसीटेट आयन थोड़ी सी और इन्वॉल्व हो जाएगी बट सो कर सकते हैं. So if I'll add here, so acetate ion will also form identical resonating structure and bond order becomes 1.5. So because of identical resonating structure, bond order will be 1+1/2, which is 1.5. So now if I'll compare the CO bond length and CO plus is highest, then it is, oh, sorry, bond strength, what will be bond length? If I'll say so, it is CO plus is least, then it is CO, then it is CO2, then it is acetate ion, and finally it is carbonate ion. And likewise, different type of questions can be created here. ठीक है.